Okay, hello all. So today is the live coding session. I have 7 problems for today. Okay, just sharing the screen. Yeah, my screen is visible.
Yes, sir.
Okay. Okay, let's start. I am just releasing the problems for the week 3 live coding. These problems are similar to week 3 assignments. Okay, week 3 assignment concepts. So okay, I'm releasing all uh, all problems at the same time. Okay, just open your Replit and start the coding. Yeah,
Certainly.
please confirm that if problem are visible or not.
Yes, sir, they're visible.
Yeah, so just start from the problem one. And so try to complete problem 1 to 6 before 7 o'clock. Okay, after that, because problem number 7 it is totally new type of problem, so it's take time. If you have any doubt in any problem regarding to understanding, so you can ask in between. Yeah, Mehak Single, you don't have any link for this thing, because these links have already sent to all the PDSA members.
Is it in the mail?
But we have already sent approx 10-15 days.
Just open Replit. It will show there.
Just open the Replit with your IITM email ID.
Okay.
Okay. Yeah, okay. I'm sending the invitation link in chat box. If you don't have the invitation, so you can join from the link.
Hello, sir.
Yes, yes. Who is this? Asraf.
Sir, yes, sir. Sir, can I get a link, sir? Replit link, team link.
Okay, yeah. Okay, okay.
Thank you, sir.
Wait. Okay, yeah, I've already sent in the chat box. Just see the chat box and join the teams. Okay, Asraf? Yeah, okay.
So, can you please check my code? It's not passing any test.
Yes, who is this?
So, Mehak sir.
Mehak. Okay. Wait. This one.
Yes, sir.
Okay. So what are we doing? Insert. Let me insert self return. If self dot head is not equal to none. Does not equal to none. Okay, you are inserting the element in queue. Where to do self dot last equal to return. Oh, okay. Actually, you have to take all the condition when you insert the first element. So how you can insert the element? Okay, so there are two, three condition in when you insert the element. So okay, I'm showing how it is working. So my screen is visible for writing.
Yes, sir.
Okay. Actually, what is linked list? So there are two pointer. One is head. Okay. Head pointer is point to the first node of the list. Okay. And second is last. When you insert any element in the list, actually we are implementing from the linked list concept. Okay. So there are two possibilities when you insert the element. So maybe linked list may be empty in the first condition. Okay, so you have to take a first condition if head equal to none. ठीक है, self dot head equal to none. So that means linked list already empty. So at this condition you have to add one node, first node. So there are two pointers here. So first is data and second is next. So you have to point head to this node and as well as last to the same node. This is the first condition when linked list is empty. In the second condition, when linked list is not empty, in that case you have to insert in the last only. So this is the first condition, and second condition, if linked list is already have any elements, so at this time you have to insert element here. So you have to check first this condition. If this condition is true, so you have to write like self dot head equal to node which you have created and self dot last equal to node. Okay, if this condition is true, else you have to insert the element in the last position, because we can insert from the last and then remove from the first in the queue. So in the second condition, else condition, you have to add element in the last condition, last position. So you have to take two condition to solve the problem. So I think that you just take only one condition. Okay. Self dot head not equal to none. Okay. Can I update your code, Mehak?
Yes, sir.
Okay. Just wait. So first you have to create the node. You did not create any node here. So when you are inserting a node in the list, linked list, so you have to write just, for example, new node equal to, you have to call the class node, N-O-D-E. Okay. So one new object is created, class node. After that, you have to check the condition if q self dot head equal to none. That means if head equal to none is only one case, when the list have no element, q have no elements. This is possible in only one case. Okay, so this is the first condition. In this condition, you have to add self dot head equal to new node. Okay, and as well as self dot last equal to new node. So this is the first condition when we are inserting in load when queue is empty. So if you see the diagram, so you have to fill this pointer as well. When you insert the one node like this, so after assigning this pointer, you have to fill this next field, because if queue have only one element, so there is no next node inside the list. So you have to fill none here, and data inside data already filled. Yeah. So Okay, so we are not passing here data, so data we can pass. No, this one. So you have to mention one pointer or more to self. No, self. No.
So when you write self.head equals to new node, it doesn't create the same copy. It creates a different node, right?
Yes. So new node is a totally different class.
So when you write self.head equals new node and last
Yes.
node,
This self dot head is related to this queue. The self dot head and self dot last. So queue have only two pointer, head and last. Okay, so head point to the first node and last point to the last node. In the
So,
list. Yes.
but actually, I created the node with data is equal to node in brackets data, and that works for me.
Which one? Sorry. Where?
When we are creating the node for the data,
Yes.
I wrote it as data is equal to node data, so that actually works for me.
Data equal to node data.
Data, yeah.
Yeah, you can take any variable here.
Like you can take the same value, same name that is given in the bracket.
Yes, but it will confuse. So don't take a similar variable name because we are using the data terms for the value here. So it maybe create some problem in the for the output. Okay, so new node actually this is the separate class. So we are using these node only for the node. Okay, so each node have two fields, one for data and second for the next pointer, which contain the address of next node. So when queue is empty, we create the new node. Then if queue is empty, we will fill all the value. So head equal to new node, last equal to new node, and then new node dot which will next. So next equal to none. This is the first condition when queue is empty. Okay. And second condition if queue is not empty, else. So in that case, you have to add one new element in last. So we can remove element from the last as well as delete. Okay. Okay, in that case, and the second case, so you have to add in the last. So self dot last is a pointer which contains the reference of last node. You have to just write self dot last dot next equal to new node and new node dot next equal to none. And when you added the new node in the last, so last you have to change the last point. Self dot last equal to new node. So this is the code for insert. So second condition, okay, let's tell that. This is the first condition and this is the second condition. If you have already element in the list, so when you want to insert more elements, so what you did, so you have to insert element node here. So what you have to do it, add which contain the address. For example, you have many element already in the list. So last this. Okay, you want to insert one more in the queue. So you want to insert one new node here. Okay, so what you have to do change in the list. So you have to, because in the last condition, the none is here. Okay, in the last node next field, you have to change this field value. You have to insert last self dot last dot next. So self dot last represent to this last contain the reference of this node. So you have to dot next. So dot next means this field. You have to assign the address of new node here. So this will point to the, that means you remove the none and just assign the reference of new node here. And after that, you have to fill none here because there is no node after that. So just write the new node dot next equal to none. Okay, and after adding, this is the last node now. So you have to change the point last equal to this one. So self dot last equal to new node. This is new node. So this is the basic concept to adding the code.
Hello, sir.
Yes.
Hello, sir.
So
Sir,
this is the
could you,
insert, Mehak.
Yes, sir.
Yeah, this is the insert code. You can just try to write that for the delete. Okay, just remove it. Yeah. So this is the for insert, and you can try for the delete now. Okay, man.
So my delete is I think right.
hello, sir.
Yes. Yes. Who's this? Rakesh.
Hello, sir. Yes,
Yes.
sir.
Yes, Rakesh.
Sir, could you check my code?
Okay. Okay, Rakesh. Okay, I'm just checking out.
Sir, it is saying inconsistent use of tab. This is saying and space in indentation. I cannot find the.
Okay, Rakesh. Okay, just wait. Okay, Mac, just try to write the code for delete now. So Rakesh. Rakesh, I'm not finding your ID. You just refresh the page. Oh, okay, at the rate Rakesh. Okay. No, okay. Rakesh KR123.
Yes, sir. Yes, sir. So in the test cases, it is saying that indentation problem here.
Yeah. Okay. Actually, you are not following the indentation like a previous code. Okay. So just follow this indentation in the previous DEF init. Okay. And just wait.
Okay, but in my console it is okay, I think.
Okay, I'm just changing the indentation.
But sir, my console and your console are different.
Yeah, actually, I am using the four space for the tab.
Okay, okay.
Just wait. What is the tab indentation is still TF insert cell data.
And I think the logic is also a little different because I inserted in the first position,
Oh,
but I have
you
to
are
insert in the
in the
last
first
position.
position. Okay, but actually, I've already used the traverse list here. So I think you have to insert at the last position, otherwise output will not match.
Okay,
Because
sir. But
this
there
traverse,
was indentation. Yeah.
yeah,
Okay,
this
sir.
is
Okay, sir.
indentation error. Okay, just write from here. Okay, just back and def insert. Okay, I'm just trying self data. Okay, ELE. Wait. So now the indentation is coming. Delete cell. Okay, so I write code here. Oh no, error is coming here. Okay, now it's running. Okay, now write your code.
Okay, sir. Thank you.
Okay.
Sir, I'm facing problems in the second problem.
Presta.
Yes, sir. Two
Second.
test cases are passing, but two are still not passing.
Oh, okay. Presta, just wait. I think you can see the test cases. What are the difference?
Yes, sir. So what is happening is it's giving an error that two cases are passing, but in two it's saying that the uh, uh, it is none type object, so it won't have none at it
Oh.
doesn't have next attribute.
Okay. So this is the insert in between. Okay, this is the between. Okay. Insert and self data.
So this code was already there. My code, the one I've written, is below. Insert at position.
So I'm opened your applet now.
So the insert at end function was already given. The one I've written is, yes, this is the one.
This is the one. Okay.
Yes.
Okay, then set at pure self data pure self count equal to self dot head. Okay. Count equal to 1 while count is less. Next. Okay, can I run this code? Okay, just take input here now. Let's see what is that. Okay, development type object is not group next. So line number 29. This one while. Okay. Temp equal to temp next. So temp self dot head. Okay, self dot head. Okay. Oh, I think you are not using self here. Self, self dot self dot head is okay. Wait. Okay. Actually, you have to wait just okay. Yeah. Yeah. So count value is not increasing inside here. You use the condition count for the count the value,
Oh, yes, sir.
but you are not
Got
changing the
it.
count. Okay.
Oh, yes, sir. Thank you.
Okay.
So could you take a look at my problem one code?
Wait. Yeah, CKG.
Yes.
Okay. Problem number. Yeah, George. Which problem number you are?
Problem one code.
Problem one.
One.
Okay. Okay. So new node equal to new node data. If self dot head equal to none, self dot head equal to new node, self dot okay, new node dot next equal to else. Self dot last dot next equal to new node. Okay, new node dot next equal to This one is correct. For deleting. Okay, so in the head position. Okay. Delete self. So if self dot head equal to is not equal to none. Okay, if self dot head equal to next. Okay, else. So what is the error?
Insert is not working, I guess.
Insert. Okay. So get 10. Expected output 10, actual output none. So you are returning anything? So in delete, actually, I think you have to return the deleted element value.
Okay.
Okay, so just read the value of first node and return it after deleting. Okay, got it?
Yeah.
George got, yeah.
In the test cases, it seems insert is also not working. Can you just check?
Which one? First.
The insert function. Yeah.
No, it's insert. I think it is fine. Insert it is fine. Okay, just wait. I'm adding the one line here. Item equal to self dot head dot data. I think we are using data or value data. Okay, data. And just return it. Return item. Okay.
Okay.
So actually error is coming from just you are not returning any element. So otherwise your code is correct.
Okay. Thank you.
Okay.
Hello, sir. Hello.
Wait. Yes, yes.
Sir, can you check my code? It's pass only one test case. Problem one.
Problem one. So Mr. Okay. Mr. This one. Okay, return P. So what is the output? Fail, pass, fail, fail, fail. Oh, I think you are returning some object here. Otherwise everything is okay. So in the delete function, what are you doing? If self equal to return none. Okay. Okay. Return P. Okay, so self dot head dot data. And the same thing here. P dot self head dot data. Okay. Actually, you are assigning P equal to self dot head, which means you are a reference. You are assigning a reference of node, not a value.
Oh, okay, okay.
Okay, so I
Okay,
just
sir, got
added
it.
the dot data, so all test cases passed now.
Okay, sir. Thank you.
Okay.
Sir,
Yes. Yes, Prishta.
sir, I'm a bit confused about problem 4. I'm not able to
Uh,
understand how to implement what to do with the two queues.
you have to use only two queues, maximum two queues for implementation of the stack.
Okay,
So,
sir.
okay, just try to find out the logic. So here stack is already assigned in the constructor, self.q1 equal to q, self.q2 equal to q. So there are two q already initialized in the constructor. So you can use only these two q for implementation of the stack. Okay, so you have to write just to push operation, pop operation, and other one is empty and top. Four method you have to write.
Hello, sir.
Yes, Rakesh.
Sir, it is again saying indentation problem. So, sir, what settings should I change?
Okay, I don't know which problem.
Sir, problem 1. I'm still in problem 1. Can you please check?
Okay, wait. Rakesh. Rakesh, This is your tab array.
Yes.
Use tabs and space indentation. Self dot head. Number क्या रहा? This. So this time you are doing wrong. Actually, you are defining a function here. So you can how you can go out of the scope.
But sir, my console and your console is different.
No, this time I am opening your console. Yeah.
But still, sir, the video I can see you and my console is different.
Oh, still error is coming. What is the indentation issue here? Same thing once again. You have to write from here. If self can you check again?
Yes, sir. I'm checking. Yes, sir. Now only one test case is passed.
Oh, I think this will be the code error. Let's check what is the pass, fail. Okay. And the public has no attribute next. Okay. So this is your insert condition. Okay. So I think this is not a sufficient code for insert. You have to take more condition here. You did not fill all the field of the node and as well as the queue. Okay, I'm changing the code. First, you have to just declare the node.
So,
Yes,
should I mention the head dot equal none? Should I mention it?
Okay, I'm just updating your code. Just see it. Okay. So you take you create the node. This is okay. If self dot head equal to none, okay, this is okay. If self dot head equal to none, that means queue is empty. You are inserting a first node. So you have to assign self dot head equal to ELE as well as self dot last. In this list, we are using one more pointer last, which contain the reference of last node. So you have only one element, so this is the first, and this is the last as well. So ELE, and this is the first node, so there is no
Okay,
node
sir.
after that. So you have to fill the ELE dot next. ELE dot next equal to none. Okay, this is for when you insert the first node. After that, if you insert else, self dot last dot next. Okay, this is okay, correct. And you have to mention that ELE dot next equal to none and self dot last equal to new ELE. So this is now complete insert.
Sir, why we are putting this? Yeah, sir, why we are putting this ELE dot next equal none?
Because we are inserting the node in last. Okay, in the last
Okay.
of linked list. So there is no node after that this node. So we have to fill the next pointer as a none, because there is no
Okay,
node
and
after that.
if I put the ELE dot next equal none line after creating the node, will it be correct or wrong?
Yes, it will be correct. If you mention this control X, you can also mention here. Okay, you can also remove from the as well. It is also correct. Okay,
sir.
because
Now I got it.
we are always at this node at the last position, so you can fill before that condition. Okay, just run the
sir?
test. Wait.
So still some test cases are failed.
Yeah. Now this queue, this insert is okay, and now just check the delete method.
Okay, sir.
You
Okay,
did
sir.
not return any element details in the delete function, so you have to mention the return which element are deleted. Okay, just read the question and see the output format.
Okay, sir.
Okay. Yes.
So like in the this
Yes, Prashta.
code, we had to explicitly say element dot next is equal to none. So is that necessary? Because I think when we are making the new node, it is happening by itself.
Okay. I got it. Your point.
I
Yes. You can
skipped it
remove.
because of that.
Yes. You can remove. You can remove now. It is also correct, because by default already this will fill by the constructor. Yes, you are correct. Okay.
Hello, sir.
Yes, Sandeep.
I just had a pop-up saying content diverges, and when I choose to restore my content, some of the codes I had was deleted.
Which problem?
Problem number 4.
Problem
I
number
joined a
4.
little late, so I skipped problem number 1, completed 2
Okay.
and 3, and now currently on problem number 4.
Okay.
Now it's gone. It's not there anymore, but a couple of lines got deleted. Just wanted to inform you.
So I think this is because of your replit issue or net issue. So after submitting, you have deleted something.
Okay, thank you, sir.
So could you please look at my problem 2?
Yeah, okay, George. Okay, just problem 2. This is now.
Yes, sir.
Mhm. Let me- I think some network issue. Inside your controller. Okay. Oh, you are writing everything inside the while loop, and I think while loop is not terminating. Okay. New node equal to node data. Okay, CTR count is 0. Temp equal to self.has while it's not equal to none. Actually, you have to reach till the position. So you have to use the counter in the while condition, not temp. Otherwise, if you are not using a counter, so you have to break after that for the counter. Okay, I'm just changing the logic here. Okay,
Okay.
Josh?
Okay, sir.
Okay, so you have taken a one counter, so this value will start from the one position. When temp equal to self.have, that means we are at first position. Now inside this, we have to use CTR while less than equal to POS. Okay, POS minus 1. Okay, so you are increasing position here, control X. Oh, I got it. You have to just temp equal to temp dot next and CTR temp, sorry, plus equal to 1. After that, you have to out of the loop. So what is this condition? If CTR equal to POS, okay, we have already covered this. So we are removing this now. So temp dot next equal to new node. Okay, temp is the first condition. So temp equal to, oh no, you will lose the information. First I'm writing the code, after that I will try to understand. Okay, with the temp, just take one extra variable, temp 1 equal to temp dot next. Okay, now temp 1 is done, you know, this is okay. Temp 1 here, temp dot prev equal to new node dot next equal to temp 1 new node dot prev equal to temp. This is test. Okay, now this is the correct code. Okay, now I'm trying to what is happening in this code. Okay, just wait. For example,
In my original code, if I had put in a break after
yes,
within the
yes,
second condition, it would have worked.
yes, it can be work that. So what is happening? For example, if we have a list, so this is head. Okay, so this is the first node. There are three elements in each node, and every node connected this point to this one and this previous point to this one. Okay, like this. This is none, or this is last pointer. This is head pointer. If you want to insert, for example, third position. Okay, the third position means here. So you have to, when you assign these temp equal to head, so temp is here, point to this node, and you assign counter equal to 1. So you have to take condition C when while C is less than POS. POS is 3. So 3 minus 1 is 2. Okay, you have to increment the temp field into the next node. So first C equal to 1, then 1 is less than 2. Just increase the temp to the next pointer. Temp is now here. So C become 2. Now 2 is less than 2 is condition. This is condition false. So finally we have a pointer for the second position node. After that we just take a one more variable temp1, which is temp dot next. Temp1 address is here. So we just copy temp1 equal to temp dot next. So now temp point to this one and temp1 point to this one. Now we are adding one new node in between. So we have to just add the temp dot next equal to this one. Okay, temp one previous dot previous is to this one, and we have to fill this these two fields as well. So new node, this is new node. New node dot previous equal to temp, and new node dot next equal to temp1. So this link will be created. So like we are coding like this. We are filling the all pointer. Yeah, this one. Okay.
Got it, sir. Thank you.
Sir,
Yes.
sir,
Yes,
can you
ma'am.
explain the fourth problem because I'm stuck in that. It's only passing one test case for me.
Okay, Nandika. Wait.
Thank you, sir.
Problem. Stack implementation using 2Q. Okay. Stack implementation using 2Q. Okay, you write the code post pop. Thank you. It's a code for while child will not be take. So take you. You are not getting this. Okay. So Nandika, what are you doing till now in this problem? Do you have any logic for that?
Sir, I'm just copying like from Q1 to Q2 and then again from Q2 to Q1, something like that. I didn't know. I just did something. But it's only passing the fourth test case.
For past.
Yeah, it's only passing fourth, I guess. I don't know. As fourth test case.
Oh.
I'm showing some error that's like list object as no attribute.
Yeah, so 1 is past and 4 is fail. Okay.
Sir, could you also please discuss the logic we should go
Yes, sir.
through, because even I'm not able to figure it out.
Okay.
Sir, can I share how I wanted to implement this?
Wait, which one? Sandeep. Hello?
Yes, sir.
Yeah,
Yes, sir. I'm currently on this problem.
Do you want to explain?
No, no. I just wanted to share how I wanted to implement this using 2 queues.
Okay, okay. I'm just sharing your screen. Okay.
Okay, sir.
Sandeep, do you are asking for me or you want to? Okay, you want to share.
Actually, sir, I need your help because I am having some problem. But just I wanted to share how I implemented it
Okay,
and
just
where
I'm
is the
opening.
problem.
Okay, I'm opening your.
Okay.
Wait. Sandeep, problem number 4. Yes, Sandeep. This is your code.
Yes, sir. I just wanted to use one of the queues to populate the data I am getting when I'm using the push method. Suppose
Okay.
Suppose
Yeah,
the push
okay.
method is
Yeah,
called
I
4
got it.
times.
Yes, I got it.
I only populate the first queue, the second queue is empty. Once I wanted to know the top, if once I wanted to know the top, what is the last item that was
Yeah.
pushed, I will just dequeue all the elements from Q1 and I'll reduce the self size from n to unless it becomes 1, and then I'll save the last element as in a variable, and then I'll return the element, and then again I'll enqueue the list 1. So Q1, so the normal condition is restored. but
So
I am
your
having an
code is
index error.
oh, index system.
Yes.
Text was far. Okay. So index error for example this.
Somehow my when I'm
From
trying
empty
to get
list.
the last element, the
Yes, yes,
queue
yes.
is empty already.
Yeah. So you have
So
to
I'm just trying
validate
to
this.
debug.
Okay. Okay, I'm just
Can
giving
you check?
some hint. Wait. Actually, what you have to do, you have two queue. So for example, you have to. Okay. What is the logic? Okay. So in queue, you can insert from the last and remove from the first object. So for example, this is front or this is rear. Yeah. Okay. So you have to use one queue for insert the element. So for push operation, you have to use one queue. For example, if you are using a Q2, so for example, you want to set 10, 20, and 30. So what happened? Just push operation. Use Q2. Push will become from DR. So initially, first this is the case when empty, Q is empty, so 10 will come here. Okay. After that, you have to some logic is here. Correctly, why? That is after inserting the first element, you have to swapping the name of these queue. I am talking about just a push operation here. Okay, push operation. So what happening here? You have to swapping the. For example, I have after inserting the 10. So now Q1 is empty. Q2 is have a 10 element. So we will change the name of these queue now, like this for Q equal to Q1 and Q1 equal to Q2 and Q2 equal to Q. So we will replace the name. Okay, I am replacing the name here in the after the first insert. So for example, after inserting this become a Q2 and this become a Q1. So every time we insert the element in Q2 list. So now in the second, when we insert the 20, so 20 will be inserted at this position. So after that, we insert all Q1 element. We remove all the Q1 element from this list and insert to the Q2. So 10 will insert after here. Okay, now swapping the name once again. Now this become Q1 and this become Q2. Okay, so this will become empty now because we have already inserted this here. Now 30 come here. So 30 will come at the first place. So now 30 come in Q2 and then remove all element from this list Q1 and insert into the this Q2. So 20 come here, then 10 come here. Okay, now replace swap the name. Now this become Q2 and Q1. Okay, so now this become empty after removing all elements. So for example, if there is a one more element 40, so 40, if we want to insert 40, so Q2, it come here 40. Okay, now removing all Q1 element one by one and insert into the Q2. So 40, after that 30, then 20, then 10. So we repeat this step each time when we insert one element in the list. Okay, so we have list now Q2 in the final. When you want to pop operation, so when you want to pop, so just remove element from the Q2. So Q2 will be for in this list. So Q2 at the first position, 40 at the first position, which is the last inserted element. So when you want to pop operation from the stack, so you have to remove one element from the queue in the first position. So output will be 40. After that, if you want to once again pop, so next 30 will be, next 20 will be. So this is the swapping process is here for the logic. Just change the name of the queue. Swap the name of the queue after each time inserting. Each time insert the element in Q2 and remove all element from Q1 and insert into the Q2. After that, just swap the name of the queue.
Thank you, sir.
This is the main logic, yeah.
Hello, sir. Can I just make one small comment? Like I did something similar to this one, except that instead of swapping the names at the end, I did a while loop again, and then put the all the elements back into Q1 again. But I guess your this one is more efficient.
Yeah. So just you can create something new if it is working, then it will fine. Yeah.
Yes, sir, it passed, but yeah, I just want to say that yours is more efficient.
Okay.
Hello, sir.
Yes, Mr.
Sir, can you check my problem tree? It's not passing any test case.
Which problem?
Problem 3.
Problem 3. Okay.
Yes, sir.
And delete code. Delete from position. Okay. Third position. Count equal to. Why you take count equal less than POS minus 2?
Sir, I just want to fix that position where I have to delete the before position of deleting the element and the after position of deleting the element.
Okay, check, yeah. So count plus 1 temp 1 equal to 10. Next, okay. Drop node equal to temp 1 next, okay. Temp equal to drop node dot next. Okay. Oh, okay. So now temp 1 have the previous node of the drop node and temp 2 have the afterward. Okay, so drop. Okay. Now you have to link these two nodes directly. So what you have to do? So you connect the temp2 dot preview equal to temp1.
Sir, but I connect temp1 and temp2 na?
Yes, I already connect temp1 dot next equal to temp2. Okay. Return drop node. Oh, you just return the directly node. You have to just return the value here. So value, what is the value field? Last
Data.
yes, data. Okay. Dot data.
Still two test case
something.
failed.
Yeah, so what is the so expected output? I think something I missed. For example, user list of POS. So I think POS just change this condition. Okay. And dot then equal to self dot head count equal to word count is less than the POS minus 1. POS minus 1. Third node is third. Next. So then these things. Comparable components. There is my 10 code is looking correct. The problem we just check here. 10, okay. And if you want to remove three third element, so what is this is 40, so we are going more, so we have to just decrease one.
Was minus to that.
Comma, comma, 50. 14, comma, 50. Okay, and third element.
So can you write was minus 2?
Minus 2. Minus 2. Okay. Oh, now it is okay. So I test is not fast. Failed.
Yes, two test case still failed. Fine.
I think you did not take any condition. Condition is, I think there's no condition here.
Yes, sir, there is no condition.
What is the difference?
So one lesson was less than enough list. That condition I have to put or not?
No, actually, no, not required. Actually, there is no test case related to this. So 20 is removed. Actual output, expected actual output based one. So 30 is related. 20, 30. So sometime it is working. Okay, just I'm creating the solution code which I am remembering that. This is your code. Yeah, but so what is the difference? While C less than equal to POS. So for the 10 next. And dot next. And 0, 1. Okay, after that, so we have reached at the position. Okay. So 10 equal to 10. What PREB? Ten. Next. One, four, two, two, two. You are deleting now. Oh, I think one condition is missed.
What's that?
Actually, okay, I've got it. Your code is okay. Uh, Actually, if I am deleting, for example, what happened? Completion. No, I think this is. Okay, just try it. Complete it. 10
Both
to the-
look same, na?
just 10, 1. Okay, and return 10 dot data. First. Yeah. So what is the difference? Okay, can you see POS canticle temporary quantity UT POS minus 2. I think it is very far. This is not least at the right element.
Sorry, sir. I can't understand.
Temp count is less than POS minus 2. Just take an example and understand how your code is working. Okay, for example, if we have a list for the middle element, we are taking for example, there are hello, am I audible?
Yes, sir. Yes.
Actually, my screen is stuck. Just wait. Oh, what is that? Sorry, I think something problem in my system, so this is not working now. Just wait for a 2 minute resolving now. What happening?
Okay. But sir, I am getting one point. When there is only 3 element in a list, then
Yes.
it can't get temporary element. That's the fact.
3 element in the list, so we are not asking to remove first element as and last element.
No, I am telling that suppose there is 3 element in a list and I
Yes.
want to delete middle element. Then if I write temp -2, then it
Two.
can't get the temporary element. That's the fact.
Yes, you are taking a less value for the
Correct,
counting.
sir. Okay, I got it now.
What happening? Just wait. हेलो। हाँ ओमकार, एक्चुअली पता नहीं क्या मेरा सिस्टम बिल्कुल एकदम से वो हो गया है, लॉक हो गया एक तरीके से, कुछ भी नहीं हो रहा उस पे। तो कोई टेक ओवर कर सकता है मतलब सेशन को? नहीं चल रहा है सेशन, अभी मैं बंद नहीं कर पाया क्योंकि मेरी तरफ से मतलब कुछ इशू है, लैपटॉप एकदम से बिल्कुल ब्लॉक है शायद। हाँ। हेलो। हाँ ये बिल्कुल ना कुछ मैं कर नहीं पा रहा हूँ उसमें, मतलब ना तो बंद भी तो नहीं कर पा रहा हूँ, मेरी लैपटॉप की तरफ से पता नहीं क्या, कुछ भी कंट्रोल नहीं कर पा रहा। अच्छा बच्चे भी कर रहे थे एक्चुअली, पूछ भी रहे थे वो कुछ। हाँ वो प्रॉब्लम पूछ रहे थे एक्चुअली। अच्छा अच्छा, मैं एक्चुअली रजत को कॉल किया तो उसका नंबर लगा तो। वैसे मैं एक बार रुको, एक पावर शट डाउन करके बस चेक कर रहा हूँ अगर शायद चल जाए। क्योंकि बीच में से बच्चे पूछ रहे थे ना, एकदम से थोड़ा सा चला था। 12 13। ओ ओके ओके ना आई थिंक, ठीक है हो गया। ओके। हेलो, am I audible?
Yes, sir.
I think some issue comes in my laptop. It's totally stuck now.
Take on,
Uh,
please.
okay, if anybody have any problem in between, so you can ask now. Who is the last one asking for the question?
So I was having problems with
Uh,
the sixth problem.
Problem number 6.
6.
Okay. What's your name?
Prestha.
Okay, Prestha. Wait. So, okay, now what are you doing in this code? So actually this problem is you can solve by the quick sort algorithm.
Sir,
Okay,
I tried
and,
that, but it was giving index error. So I thought let's try selection, but this is also giving index error.
okay. So actually I'm giving the input in the tuple form here. What are you doing? Index 0 for a. Okay. You are swapping the elements in this lesson. Last time shortlist L index and shortlist L index. It's not passed.
Sir, no test case is passing.
So index error in this condition while this index out of range. We are reaching here. If n is less than equal to 1, return air for I in range. And j equal to I going. No, I think this is not which method you are using. You are using bubble sort, I think.
No, sir, selection sort.
Okay. No, in this concept, I think this is bubble sort concept for sorting element.
Okay, sir, I'll check again.
No, can I write the quicksort solution here?
Yes, sir, sure.
Or you want to try? Okay, I'm just writing the solution. Okay. Commenting your code. Yeah, this is the quicksort algorithm. Okay. This one is the quicksort, and this is also a quicksort. But just I changed the name of the quicksort algorithm. This is in the first time I have take pivot equal to f. Hello.
Yes, sir.
Yeah. Okay. So this is also a quicksort algorithm, but we are using a one step here. We are not recursive this function inside this function. Okay. But this method is a partition method for the quicksort algorithm. Similar to, and we are taking a pivot equal to f for the first partition. Okay, and comparing the second index element to the pivot each time. So this part will return the list up to the partition of male and female. So all female comes before the male only by this code.
Okay, sir.
Okay. After that, we just call the quicksort for each partition. So quicksort algorithm is this. So this will sort internally. So this will sort the male partition, and this will this will sort the female partition internally. And we are taking a pivot element similar to first element as a pivot element. Just read the value of first index for the pivot, because we are sorting the a list by the appointment ID. So I'm using one quicksort algorithm completely, and one is the partition part. So you can arrange these in this way.
Okay, sir. Thank you.
Okay. Okay. So how many students? Okay, 14 submitted first, 11, 7, 0. Problem number 3. Yes.
So for that problem the 6, are we allowed to use the like default Python function, like the sort function?
Yeah, you can use.
Okay.
Okay,
Because
you can use
yeah.
if you found any logic, so you can use.
Yes,
Otherwise,
one logic was there.
Yeah. Otherwise,
Yeah.
this problem can be solved by the quicksort algorithm.
Okay. Like the logic I found was
Before
that if it is male, if it is male, like I add a very large number to it, like say 10,000, and then add the I think it was the patient number to that a large value, so that when it gets sorted, it will automatically be in the back of the list. Like the males would be in the back of the list and females would be in the front of the list, like that.
Okay, okay. Then you can try, but after that you can also try with the quicksort as well. Okay.
Okay, sir.
With the algorithms, yeah. Yes, Alice.
Hello, sir.
Yeah, why you submitted a problem without writing any code?
Sorry, sir. Yeah, by mistake.
Oh,
Mistake.
okay.
I was submitting problem with this mistake.
Yeah, I just see the problem number 6, and this is you are not writing anything. You submitted. Okay, this is the summary of today live coding session. So, problem number 1, 15 have submitted, 2, 14 have submitted, and third 10 have submitted. After that, problem 3, sorry, problem number 4, 5, 6, only 4 or 3 submitted now. Okay. So, if anybody have any doubt in any problem logics, you can ask now. Otherwise, we have to close. So, any query regarding any problem or any logic finding?
So problem 4 and 5, that is implementing stack using queue and queue using stack.
Okay.
It's not clear to me how to implement that.
Sir,
Actually,
sir.
in the problem number 3, you have to use the logic by just swapping the name of the queue after inserting the element. I've already discussed with one student. So, okay, I'm just revising that. What is the logic for problem number 3?
4, sir.
This is 4 and 5.
4, yeah, it's, stack using queue and queue using stack, no?
Yes.
Okay, I'm just describing the logic, and after that you can try. So what is we are actually when we are implementing the stack, so we are taking two queue, okay, Q1 and Q2. So initially the name of this one is Q1 and this is Q2. And we want to insert, for example, we want to post post 10, 20, 30, 40, and 50 inside the queue, but we want to work as a stack. So first element is the 10. So always when we insert the element, we will insert into the Q2. Okay. So always we every time when we call the operation post, so we will insert the element into the Q2 list. So for example, we are inserting the 10. So this will insert here 10 in the first position. Okay, because Q is empty, so element come on the first position. So after that, inserting the element, you will read all the element of Q1 and insert into the Q2. But in the first element, there is no element in the Q1. So there is no effect. So after inserting the 10 inside the Q2, you have to swap the name of Qs. So initially first Q1 representing to this one and Q2 representing to this one. So after inserting the 10 here, so we will replace the name of Q. So you can replace by this like this: Q equal to Q1 and Q1 equal to Q2 and Q2 equal to Q. So after inserting first element, and now this Q become a Q2 and this become a Q1. Swapping the name. Okay. In the next push operation, 20 will come. So every time when a element comes for the insert in the stack, so it will insert into the Q2. So what now Q2 is this one. So this is empty. So 20 will come here in the first position because it is empty. So after sorry 20. Okay. So 20. After inserting 20, you will insert all the element, you will remove all the element one by one from Q1 and will insert into the Q2. So there is only one element in Q1 now. So you will remove this one and this will come here. So 10 come here. Okay. So now in this step, and after the inserting these elements, so you will just again swap the name. So now this become Q1 and this become Q2. Okay, when 30 is coming, then 30 come on the Q2. So 30 come here. Okay, so you will remove all the element from Q1 and inserting into the Q2. So Q20 come remove first from the Q1 and add here. Then 10 remove and add here. Okay, so now it become empty. Okay, just swap the name once again. Okay, now this
so this NQ function is adding it to the beginning of the queue.
Actually we want to perform as a stack, no? Yeah, in queue operation, queue operation always insert a new element. It will be inserted at the last and remove from the first. Okay, in queue operation, insert element at the last position. If you have 10, 20 already in the queue, so next element will become after the 20. When you want to remove DQ operation, when you want to perform DQ operation, so always it will come from the front. So first 10 will be removed first. Okay, so we will have in the final, after inserting all element, we have this queue. So 10, like for example, now till now 30, 20, 10. So when you call the pop function, so what happened in the pop function? Always remove the element which inserted the last one. So we have inserted 30 in the last. So from Q you can remove from the first position. So 30 will come for the pop. So you have to just remove from the Q, but element come out 30. This will work as a push and pop operation, like as a stack. Okay, so this is the process for problem number 3.
So after inserting, we should always make Q2 empty.
Yeah, after inserting element in Q2, you have to remove all element one by one from Q1 and insert. You have to include into the Q2. After Q1 and Q2.
Hello,
Okay.
sir.
Hello.
Sir, actually, what push does, it's reverse the list.
Yes. Here we are reversing the element.
Just
This process
using
is
to
reversing the
stack.
element. Yeah, just using for the stack. Because in the
Okay.
stacks, always the last element will be removed first. Last inserted element removed first.
Okay,
So
sir.
we are just reversing the element in this process. So this is the steps for the problem number 4. And in the problem number 5, where we are using stack. We are using, for example, 2 stack. So I'm creating stack like this. Okay. So when element comes and we are perform the Q operation. Okay. So when elements comes for the insert. Okay. So we just insert into the this one. Like for example, we have a 10, 20, 30, 40, or this is S1 or this is S2. Okay. So when 10 comes for the push, sorry, for the we are performing in Q. Okay. So in Q, so 10 will come here. Okay. So what happened in the this one? So we have to push all. Yeah. Okay. So we have to remove all element from S2. We have to remove all element from S2 one by one and insert into the S1. Or after inserting all, we just remove all element from the S1 and once again we will insert into the S2. So initially there is no element S2, so there is so only 10 will come here after removing the steps. So this will become empty. Okay. Now 20 comes. Sorry. 20 comes. So 20 comes here. Okay. So this 10 will come and insert in the top. So 10 will here. After that, we will remove all elements from the S1 and just insert it to the this. So 10 here and 20 comes here. 20. Okay. Same for the 30. So after 20 come here, so this become empty once again. So 30 come here. Push. And after the 30, so we just 20. I think something. Oh, something goes. Okay, just check this. Check. Just wait up. I think someone is solved the problem. Okay. Okay, got it. Oh, sorry. So no, this is not a correct object for this one. Okay, I'm repeating once again for the problem number 5. So we have actually initially 2 stack S1 or S2. Yeah. So before when 10, 20, 30 and 40, we want to insert 10. So we, before inserting 10 into the S1, we just remove all element from S2 and come into, push into the S1. So there is no element in S2. So this is become empty. So 10 will come here. Okay. So, and after there is no elements, then we will push the 10 here and just remove it and come here. So 10 will come here. Okay, in the next step it will be clear. So okay, now for 20, when 20 comes, so before 20 insert 20 into the S1, we have to just remove all element one by one from S2 and come into the push into the S1. So 10 come here. Okay, after that 10 come here, so we will just push the 20 here. Okay, after 20, pushing the 20 into the S1, so we just remove all element from the S1 and just push into the S2. So 20 come first and insert down, and 10 after that. Okay, 10 like that. So it become empty.
Hello, sir.
Yes.
Sir, can you again repeat the step?
Okay, just once again. So actually we have steps S1 and S2, and we want to include these elements 10, 20, 30, 40 one by one. So initially, what is the logic? What is the logic? First first operation is just remove all element from S2 and insert into the S1.
Okay.
S2 to S1. Okay. After that, second step is push inside S1. Okay, into S1 element. Okay, so 10, for example, we have n j element. Push into S1. After pushing into S1, then just repeat this process. So S1, remove all element from S1 and insert into the S2 again. These are the three steps we are following for. So in the initially there is no element in S2, so this is not working. There is no element in S2, so we perform the second step, push n. So 10 is the n value, so 10 insert into here. After that, S1, remove all element from S1 and insert into the S2. So 10 come here. Okay, so this is the first cycle for 10. Okay, so now finally 10 is come inside the S2. It comes to the next element. Okay, come to the 20. So just repeat this first step again. So remove all element from S2 and insert into the S1. So there is one element. So this comes removed from the S2 and just insert into the S1. So 10 comes here. First step. Second, push into S1. So 20 comes above of the 10. After the third step, remove all element one by one from S1 and insert into the S2. So 20 come down and then 10 come here. Okay.
Okay.
So this is for 20. Then 30 come. So 30, before 30, inserting 30 into the S1, just remove all element from the S2 and insert it to the here. So 10, 20, then after insert 30, just repeat the step once again. Okay, so 30 come here, then 20, then 10. Same once again repeat for 40.
Okay, got it now, sir.
Okay, got it.
Thanks.
So when you perform the operation DQ, so we will perform the operation DQ from S2. From S2. So first element will be deleted from this 10. Okay. So so this is the Q concept. Which element comes first will remove first. 10 comes first in the queue, and this will remove first. So always this will pop first from the DQ. So this is the element conversion. So there are this is the logic. First S2 to S1, then S all element S1 to S2 for problem number 5. And problem number 6, actually you can solve by the quick sort algorithm. Otherwise, you can solve directly just using the built-in function. Some candidates are performed by that.
Hello, sir.
Yes.
Hello, sir. Can you check my solutions, sir? I have implemented the quick
Ashraf.
sorter in
Yeah,
sir,
okay.
in problem 6, sir. But I am getting index out of
Problem.
range, sir. Problem 6, sir.
Okay, just wait. Ashraf, where is your Ashraf? Hello.
Sir, I submitted just now, sir.
Okay.
Sir, Gulam Dastagir Ashraf Khan, sir. This is my sir. Gulam Dastagir.
Oh, this is your okay.
Gulam Dastagir.
Okay, you define the partition name, arrange. Okay, you call the partition here. Okay. And this is the same algorithm which we used to. No, this is, yes. This is okay. So what is the error?
Sir, index out of range, sir. In line 20, sir.
In line number 20. So in line number 20.
Sir, I have checked my partition function, sir. It is working fine, sir.
It is working. Okay. So after that, you call the quick sort algorithm here. So L is less 0 F. So what is partition return?
Sir, partition.
FM.
Yes, sir. This returns the F returns the value up until which female have, sir. Female index, sir. F return the last index where the female ends. No, list, sir. Female value
Okay.
ends.
Okay. And you are again starting from here. And M value just for the men, no?
Yes, sir. But
Where men start.
yes, sir. But it gives the length of list, sir, in end, sir. M or length of L is.
What is just wait. I'm taking that.
Sir, there is a in a list, sir, in first case number 5, sir, I think sir.
Case number 5.
No, sir.
What is LF? Okay, LF. Okay. Okay, just to wait. What is the date? Okay. The list. Let's look at this. Okay, and I think this is. Let's see. My spider window is visible to you?
No, sir.
Spider is not visible.
Now, sir, it's visual, sir.
Okay, okay. This is how we can put this is like back sort of range. So what is the print value? 0, 1. Finally, 2 and 7. We are getting. So Ajay, male, 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 male. Yeah. So Y value 2 and 7 are returning by F and M. I think this is not working correctly. So there are 4 female. 1, 2, 3. Sorry, 1, 2, 3, and 4. Yeah. So there are 4 female and 9. So 5 male in the list. So your partition function is returning 2 and 7 as value. Okay, just add 4, 4, 4. For a particular example. So I think your partition function is not working correctly, not returning correct value.
Okay, sir. I will check it again, sir.
Okay, if I am inserting the index, so okay, I'll insert, for example, this is 4 and this is the last one. Okay, this is there. So this is let's see what is the output for that. Still okay. So I think something is wrong inside the return value f and m. So just check again and okay. Otherwise, you are going to correct logic. Or just this is the correct method.
Yes, sir.
But something is wrong in the partition.
Yes, sir. I will try to decode bug it, sir. Debug, sir.
Okay, okay. Just changing this one. Maximum recursion depth. Okay, something is wrong now. Okay, just try again. After some time, you will get the answer.
Okay, sir.
Otherwise, I have a solution if you want to, if you need, so I can save in your replit. Do you want to the solution?
Yes, sir. You can.
Okay,
You
I'm
can
just
save it my replit, sir.
okay. I'm just copying here, so you
Yes,
can
sir.
just see the solution. Got it? So this after the
Yes,
print
sir.
statement. So this is the solution. Just go through it. Okay. Anybody else? Anyone?
Sir, how long this link will be working, sir?
Yeah, link is working. After actually, submission date is 7:30 p.m. for today, but you can submit after that. It is just only given a message to you. You are submitting late only. But
Okay, sir.
link is already open. Link is open as well for week 2 and week 1 as also.
Yes, sir. So
Link.
because I haven't attempted question number 7 yet, sir.
Okay. Solve, yeah. Okay. Okay. Okay, now George, Preeti, Asraf. Okay, I'm just closing now the session. If you have any query, you can ask.
Thank you, sir. Thank you for the session, sir. Thank you very much.
Okay.